Hello everyone, this is Rahul Hegde, third year computer science student from JSS Academy of Technical Education, Bangalore. I'm here to present to you three-dimensional third-person simulation using Unity 3D game engine, or in layman terms, a 3D video game. So let's head right into it. Why do we need it? The first answer that pops into anyone's mind is entertainment. Today, the gaming industry is bigger than both music and movie industry combined, so we know that there are a lot of opportunities in this domain. The next application would be simulation and training. Example, pilots are trained through simulators before they are let to fly a real aircraft. Other application that comes to my mind is virtual and augmented reality. With VR and AR kicking in, we'll definitely see a large surge of VR and AR application and games in coming years. Making a VR application is as simple as importing Unity's VR kit into your workspace. Technically, there is a bit of a learning curve, but game programmers find it easy and at home to work on these technologies. What constitutes it? We need all of these to make a fully functional video game or a simulation application. First is art or graphics. If your game is set in a 3D world, 3D graphics. If your game is set in a 2D world, then 2D graphics. Next up, sound design. We need sounds to add reality to the simulation. Functional coding. This is what brings the game to life and makes it function. Technology is used. I've used a lot of technologies to bring this project to life. However, I'm going to list only the programming technologies as this is a programming demonstration. C# programming language for programming the games and implementing the modules. Unity 3D game engine to compile all the art, graphics, programs, and sounds to render a fully performing simulation. Now let's head right into Unity and see the project. So this is my Unity 3D workspace. I'm going to start the project. This is my main character. The character controller takes an input from keyboard and mouse. Keyboard for directional parameters and mouse for rotational parameters. You can also see that the character has an animation controller which takes care of the animation. Now you can see that the enemies, that is the AI characters, attacking the player. The AI characters also have animation controllers attached to them. You can see that the AI will always choose the shortest path from it to the player. Every system tech. This is achieved using H-star pathfinding algorithm. Of course, I could have used this thrust algorithm, but H-star pathfinding is faster. We can also see that we have sound controller which emanates logarithmic sound from the player. We also have a camera controller which follows the player every time the player moves and goes out of bounds of the camera region. So the first question that might have popped into anyone's head is, how is the AI using H-star pathfinding algorithm avoiding all these obstacles and finding the player? Well, this is done using Unity's now mesh feature. Basically, the blue regions are walkable regions. We have to tag all the objects and components in this world as walkable or not walkable. And for example, this wall is not walkable. And you can see if you bake it right now, this part is not walkable and everything in blue is walkable. And that's how our AI will detect walkable zones from unwalkable zones. And that's how AI won't collide with walls. The next thing I would like to address is the time of the day feature. If you've seen in the last video, the simulation would start in bright light. However, by the time it ends, it's dark and the player would need to turn on the flashlight. So how have I implemented this? I made a directional light and called it sun. And each system tech, the sun would rotate around the world in which I have created. And each system tech, the shadows and lights are remapped. Let me just speed up the process for you to show you what I'm talking about.